Previously, we've multiplied binomials by using the distributive property. So if we have x plus 3 times x plus 4, you would take x times x, and that would be x squared. And then you would take x also times the 4, that would be 4x. And then 3 times x, that would be 3x. And then 3 times 4 would be 12. And then we would add our like terms. 4x and 3x in the middle are like terms, and that adds up to 7x. And that would be our answer for the product of x plus 3 and x plus 4. What we're going to do in this lesson is that we're going to factor a trinomial into a binomial pair by going in reverse. So x squared plus 7x plus 12 will be the question, and then we have to figure out what binomials would multiply together to be x squared plus 7x plus 12. So let's analyze where each one of those terms comes from. Notice the x squared came from multiplying the x times the x. That was the first term in each set of parentheses. Skipping to the 12, notice that the 12 comes from multiplying the last term in the parentheses, the 3 times the 4. The middle term came from a couple of things. The middle term started out by coming from the 4x plus the 3x, and the 4x and the 3x came from multiplying the 3 times the x and the 3 and the 4 times the x. So that's where the middle term came from. We can use all that information to help us factor. So we're going to do the answer to what we just did, and we're going to show how to factor it back into the two binomial pairs. So we know that the first term comes from multiplying the first term in each set of parentheses. So what times what is x squared? X times x is x squared. We know the last term multiplies together to be the last term in each set of parentheses. So what are numbers that multiply to be 12? One set of numbers that multiplies to be 12 is 3 and 4. So I'll put a plus 3 here and a positive 4 here. There are other numbers that multiply to be 12, but what we have to make sure is whatever numbers we put in the last position, the middle term has to have the inside and the outside terms have to add up to be the middle term of 7x. This is the part that we need to check, because we know we have the first numbers correct because we know that x times x equals x squared. We know 4 times 3 equals 12, but we're not sure if the middle term will match up. And since the middle term comes from taking the middle terms 3 times x and the outside terms of 4 times x, we need to add those together to make sure it adds up to 7x, and it does. So this is the correctly factored answer. These little horseshoe shapes there are how we're going to check it, but the final answer is the binomial pair in parentheses. So when we are factoring trinomials, we're going to attempt to factor into two binomials, which will be known as a binomial pair. This is just another type of factoring. What you learned in the previous lesson about using the distributive property factoring still applies, so always check for distributive property factoring first. So we're going to start out by factoring x squared plus 9x plus 20. Can we do a distributive property factoring? Can we factor anything out of x squared, 9x, and 20? Well, none of them, all three of them do not contain an x. The 20 does not contain an x, so we can't factor out an x by the distributive property. And since the coefficient of the first term is just a 1, there is no number larger than 1 that goes into 1, 9, and 20. And since we don't want to factor out a 1 because it doesn't get us anywhere, we can't factor by distributive property. So that means we'll go straight to our binomial pairs. So I'll draw two sets of parentheses. What times what is x squared? We're going to place that there and there. What times what is x squared? Well, x times x is x squared. What times what is 20 equal to? We're going to place that in those positions. There's actually several numbers that multiply together to be 20. There is 1 and 20. 1 times 20 is 20. There's 2 and 10. There's also 4 and 5. So only one set of those numbers might work. So which set of those numbers, when we plug them in, will give us inside terms and outside terms that add up to this 9x in the middle? Let's try positive 4 and positive 5. So 4 times x is 4x. The outside terms is 5 and x, that's 5x. That does add together to be 9x, which is this middle term up here. That means we do have it correctly factored. So the correct factorization is right there, x plus 4, x times plus 5. If you were to distribute that out, you would get x squared plus 9x plus 20. D squared plus 11d plus 24. Can we factor by distributive property? We cannot. Nothing goes into d squared or 1, 11, and 24 other than 1. We won't factor out 1s. And they all don't contain a d. So let's just try a binomial pair. D squared, the only way to split up d squared is d and d. We need two numbers that multiply to be positive 24, but add to be 11. So numbers that multiply to be positive 24, well, there's 1 and 24, there's 2 and 12, there's 3 and 8, there's 4 and 6. So let's say we wanted to try 4 and 6, so let's put a plus 4 and a plus 6. And then we check. 4 times d is 4d, that's my insides. D times 6, that's 6d. I add those together to get 10d. But I'm supposed to get 11d, which means 4 and 6 do not work. That is not the way to factor this. So I have to try something else. So 4 and 6 did not work. Let's try maybe 3 and 8. So I put in a 3 and an 8. Inside is 3d. Outside is 8d. And that does add up to 11d. So d plus 3 times d plus 8 is the correct factorization. Next one, x squared minus 8x plus 12. Can we factor out by distributive property? We cannot. So let's try a binomial pair. What times what is x squared? That's x times x. And what times what is 12, but then adds up to be negative 8? Well, it's got to multiply to be a positive 12, but add up to be a negative 8. How is that going to be possible to multiply to be a positive number, but add to be a negative number? We can do that with two negative numbers, because a negative times a negative will be a positive, but a negative plus a negative will also be a negative. So what times what equals negative 12 that adds to be negative 8? Options are negative 1 and negative 12, negative 2 and negative 6, and negative 3 and negative 4. If we do negative 2 and negative 6, the inside terms is negative 2x. The outside terms is negative 6x, and that does add up to negative 8x. So we do have the correct factorization. It's x minus 2, x minus 6. W squared minus 11w plus 28. Can we factor by distributive property? Yet again, we can't take out a variable. We can't take out a number, so we can go right to a binomial pair. W squared is w times w. Again, we have multiply to be a positive number, but add to be a negative number. So that does mean that we have to use two negatives for that to happen. And what two numbers multiply to be negative 28 or positive 28, but add to be negative 11? That would be negative 7 and negative 4. That would be negative 7w, negative 4w, and that does add up to be negative 11w. So we have the correct factorization there.